Sir, you're not audible. Let me share the screen. I have your presentation. Sir, if you allow, may I share the screen, your presentation? You can just guide me regarding the slides later on. Shall I?
Dr. Dara, can you hear me?
Yes, sir. I can hear you, sir.
Okay, do you want to just show your screen then? I don't
Yes,
think
sir.
I
Yes,
have
yes, sir.
audio and share
I
the
see a
screen at the same
technical
time.
glitch from your side. Yes, sir. Let me share your screen and you can just always deliver the session. Not an issue.
Okay.
Yeah.
Okay.
Yes, sir. You may start.
Daraban, view full screen.
Okay. So
Just a minute.
View. View and full screen mode.
No. Sir, is it okay?
yeah, please. Yeah, please proceed.
Yes.
So I was going to, if we just go back to the first slide, please.
Yes.
Just one more up. So the next slide, yeah. And if you just want to click on that link, I just wanted to show everyone the promotional video for the stadium. It's just a YouTube video. This is basically how the Supreme Committee, which is our client here. You just scroll down, Dr. Dara.
Yes, sir.
You just scroll down this page, and there's a YouTube video.
This one?
Just here. Just play that. Yeah, please.
Okay, sir.
So this illustrates the idea behind the stadium, selling the concept of reusable container-built stadium, and some images of the construction over the last 2-3 years, and every element of the stadium has been constructed to be demounted and reassembled. So a few shots of the actual finished piece. That's here in Doha, and there actually have already been games played in this stadium in the last 2 or 3 months as well. So it's been tested on all the different aspects, and it's functioning as planned. Everyone's happy to see. So we go back to the presentation, Dr. Dara.
Yes, sir. Yes, sir. Shall I move on to the next slide?
Next slide, please.
Yeah.
Yes, please. Yeah. So just a few details and an overview of the actual stadium. We've got an occupancy of 40,000 seats, area of nearly 850,000 square meters, and it'll, as already mentioned, it's one of the unique features is its demountability, and it will be repurposed and reassembled in another location, which is yet to be determined, but it will be done as soon as the games start to finish. So the last match that will be played here is the quarterfinal match of the 2022 games this year. Next slide, please. So here's a section view of the stadium, just to give an idea of actual construction and all the different elements in terms of the seating, the raked seating, the steel roof construction, and as you can see, the undercroft is where the containers are slotted in, and these are basically actual shipping containers, so they are able to be transported around the world as shipping containers. There's different modules that have been used in terms of the actual size. Some of the containers have been joined together to form rooms and complete spaces. So the whole concept behind this is the idea of a plug-and-play system, where the modules, the shipping container modules, can actually be relocated and disconnected from the main housing and reassembled in a similar manner somewhere else. Go to the next slide, please. So in terms of we've got a color coding system to denote the different functions in and around the stadium. So then it's clearly readable what the functions are. So they've got those listed there. The idea is that the actual look and feel of the stadium and the containers, they didn't want to diverge from a normal container look and feel because of the future aspect of it being repurposed and reused. So they're using readily available colors that are normally found for this kind of feature. Next slide, please. So in terms of the actual construction, there's been a BIM 360 model in use. So all of the structural elements of the stadium, the beams, the columns, and all of the shipping containers have been asset tagged with a QR code. So this code basically gives a three-dimensional position and location marker for each of the elements, which is coded back to the live model. And this basically helps teams to ensure that the right element is in the right place in terms of the XYZ coordinates. It's also going to be used extensively when the structure is demounted and reassembled elsewhere. And our team at WSP have been using this to verify the actual coordinates of the elements in the actual site and report if there's any deviation between what the model is saying and what the actual site measurement is saying. So it's been a really useful tool to actually to verify and confirm that everything is going together as designed. Next slide, please. So all the stadiums of the Qatar World Cup are being certified under a green building and sustainability system called GSAS, which stands for Global Sustainability Assessment System. So very similar to the IGB system in India, similar to LEED and BREEAM. All of these are green building certification systems, and it's actually assessed across 52 different criteria, which are divided in the headings that you see in this graphic here in terms of urban connectivity, site, energy, water, materials. All of these are headings which the standard is organized under, and this particular stadium is going for a sports certification, and it's actually targeting 5 stars. It was actually targeting 4 stars, but we've received confirmation that it's a 5-star rated design. So we've had to go through quite a rigorous process. It's been third-party audited by 𝗀𝗲𝗀𝗃𝗧, which is the authority that comes and assesses these projects. Go to the next slide. So let's have a very quick overview of why do we need these kind of programs and standards. So every time you approach any material or systems manufacturer, they will always be telling you their product is environmentally friendly, that it's green, that it does this and that. They'll send you lots of brochures with pictures of trees and all these kind of, all this kind of information that you may not have asked for. So what we're interested in is what is the item, what is the material made of, how is it processed, in the same way that we have the ingredients information on any item of food. For example, peanuts, you'll have full nutritional facts. This is the same for building materials. We want to know what they're made of, how they're made, where they're made, what is the actual components and the makeup of this material. So this is one of the main investigations that we do as a sustainability team. Go to the next slide, please.
Yes.
So just a quick overview of how a sustainability manager and his team interact with the actual disciplines within a project. So I've just put together this image regarding all the different disciplines that are involved. So all the way from the original civil engineering and structural teams, through architecture, through the actual systems, the MEP systems, health and safety, and the actual interaction with the contractor and with the actual the client body. So we interact as a sustainability team. We interact with everyone at some time in the project, and we get involved at the earliest stage to try and set the trajectory of the design and make sure that the end product is coming out as required. So for the GSAS certification, there is a 2-stage assessment. There's the design stage assessment, where the external authority verify that the design on paper is compliant with the requirements. But then they actually come on site during successive stages to actually witness and examine the structure as it's being constructed, to ensure that everything that was to be included at the design stage has actually been constructed and incorporated in the design. So this is quite a high bar in terms of compliance, and it is often the case that materials and finishes get changed through the course of a design life cycle, and this is to make sure that the actual end product is complying with the requirements, and that what is actually being created is actually a verifiable green building. Next slide, please. So we've got one of the criteria which is relevant to CEPT students in particular is the whole aspect of responsible sourcing. How are materials produced? What is their provenance? Where do they come from? How are they procured? So the actual certification system drives teams towards responsibly sourced materials. So everyone may have heard of the FSC label, which is for anything that's coming from timber products, whether it be wood paneling, veneers, even down to paper, whether it's coming from a sustainably well-managed source. When a tree is cut down, is another tree planted? This is the whole kind of way that this certification system, which is independent. They come in and independently audit a plantation to make sure that everything is done sustainably. There's also there's a British standard to actually look at this aspect, and in quite a lot of detail. It does set out what the requirements are. Also for steel and rebar construction, there's a system called 𝗀𝗣𝗧, UK 𝗀𝗣𝗧, which is also looking at the whole facility. Where is the actual ore and the material for the metal coming from? Is this mined in a sustainable way, in terms of the labor practices and all these other things? So there are independent certifications that design teams can look to ensure that they've got a very responsibly sourced product. And this is one of the ways that the 𝗖𝗄𝗧 system sort of drives this aspect in its certification. Can you go to the next slide, please? So one of the easy to understand aspects is to do with recycled content and recycled materials. So when we talk about recycled content, we're wanting to know if the actual material contains recycled content. We're not wanting to know that the material can be recycled in the future. And this is a kind of a tactic that many suppliers use. They basically put a recyclable symbol on the product, and everyone assumes that it's green in some way. But we're asking very specific questions. So on the right, you see, you probably can't see because it's a bit blurred, but there's the spreadsheet that we have to fill in to actually notify to the certification authority how much recycled content material is included in the design. And the way this is actually done, it's done as a percentage of the actual overall product, and it's given a value. So every recycled product has to be allocated a value, a monetary value, which then we can actually determine by the end of the project how much the total recycled content in. So in terms of the images you see here, there's some tiling which has recycled glass. So recycled glass bottles that have been crushed, but then incorporated into kind of like terrazzo finish. There's also recycled content in some of the concrete. So there's a product called 𝗂𝗵𝗶𝗃, which is a byproduct from power station production. And if this is incorporated into the actual mix of the concrete, it's considered to have recycled content in it. It's not always applicable for all situations in terms of its compressive strength, but it is something that's available and needs to be looked into to try and push this aspect. And also for steel, we've got lots of products that have got recycled steel in, even structural elements that contain recycled steel, and this doesn't in any way affect its structural performance or its strength. It's still a verified steel product, which just contains more waste steel that's been reintroduced into the manufacturing process. Go to the next slide, please.
Yeah.
So in terms of life cycle assessment is a way of assessing the entire life cycle aspect of a material, and the 𝗖𝗄𝗧 certification rewards products that have something called a environmental product declaration, an EPD. And this basically shows that the material and the manufacturer have gone through a very stringent process to look at their entire supply chain and their production chain to look at how this affects many different aspects in terms of environmental impact. So this is kind of like the gold standard in terms of material and ecological assessment, and more products are looking to have these kind of LCAs done to get third-party verification that their material is actually environmentally friendly. The next slide, please. So as we mentioned earlier, the stadium is fully demountable. So the image there shows how this actually working in reality. So bolted connections are what we're talking, bolted and pinned connections are what we're talking about. So all the actual steel structural elements have been bolted together. There is no on-site welding. There is no, there's nothing like that. Everything fits together like a big Meccano construction kit. And this goes all the way down to the foundations, which have been designed with lift-out loops. They're pad foundations, so they can actually be lifted out of the ground and transported at a future date as well. So it all becomes part of the system, and the actual there's been a lot of thought put into how this is actually going to be disassembled and how easy that's going to be. So the actual construction details, like for example when the columns hit the ground, you know, in this specific detail, that base plate is surrounded by just stones, which have been, you know, obviously made to look as nice as possible. But that's the way the details, the aesthetic is a very industrial look, and it's, you know, it's not meant to be pristine in the way some people would imagine some of the interiors to be. Next slide, please. So in terms of encouraging coatings that are low in VOC, so VOC is a volatile organic compound, and you find this chemical in paints and varnishes and sealants and adhesives, and especially in protective coatings for steel and for concrete. So what the certification system tries to encourage is to have low emitting or even VOC free chemicals, because they do actually affect the internal air quality of rooms, and because they actually, after being incorporated into a construction, they off gas, they release their particles into the air, which aren't very good in terms of human ventilation. So the whole aspect of being able to create a environment that isn't full of these chemicals is what's being encouraged here. And in the same way as recycled content, there is a very detailed spreadsheet that we need to fill in, and we need to examine the actual, and during the process of choosing materials and products, we need to look and ask the right questions of the manufacturers, and ensure that they can actually prove that what they're saying is actually true. So in many instances, we're looking for third-party laboratory testing to ensure that the actual end product is certified in the way they say they do, and that, you know, we're relying very heavily on the science and the technical knowledge of the actual material manufacturers to get them to confirm that what they're supplying is actually compliant. And obviously this is a way of trying to change the industry, trying to encourage the use of materials that aren't going to be harmful to occupants. Okay, next slide, please. So how is all of this organized? So on the stadium projects, we've had a GSAS material certificate that basically had to be filled in by any and all suppliers that wanted to supply any materials to a project. And this is to basically avoid the manufacturer bombarding the design teams with all the information that they want to show in their glossy brochures. And this is a way of avoiding that and saying, please just verify what is in your product. And so there's a series of fields that need to be addressed. It's not we are not of the view that every material is going to help every single aspect of the design. We are aware that some materials will be useful in terms of certain criteria, but unless you ask the question, you don't know. And at the end of the day, the GSAS certification is about is only that you only earning points and credits once you've actually proven that the material has been used and has been incorporated. So this is something that was incorporated from the outset by the design teams, by the consultants, and you know, we can actually refuse to look at an entire material submittal if it doesn't have this form in there. We can actually reject the entire thing, and this is what's been happening, and this is the way of driving the contractors to actually focus on this issue and think about sustainability in a very specific and targeted way. The next slide, please.
Yeah.
So we're coming near the end now. In terms of we've got the main key facts that have come out of the stadium in the certification phase. So we're in the closing stages of getting the finalized certificate score. So you'd be happy to know we're on the range of 5-star for this stadium. So in terms of the actual numbers, we've got nearly 25% recycled content in the entire stadium's by material value. So everything from the actual main seal structure to the actual containers, to the finishes, the flooring, the balustrades, everything was calculated. Some items had much more recycled content. For example, some of the steel balustrading had nearly 95% recycled content. But then, you know, other aspects like the rebar used in some of the foundation had like 15%. But in terms of an overall aggregate, in terms of the entire building, we've got 25%, which is actually giving us a score that's the maximum score possible for this criteria. In terms of the demountability, the disassembly aspect, that's measured at 63.69%. So there are some rooms in this stadium, for example, press rooms and media rooms that needed a higher room head height than a container could provide. So they were built from traditional construction, blockwork and steel, but everything else was, as I said, made from containers and from steel structure and stuff. So there's very high disassembly percentage, and it's being used as a case study by the actual certification authority on how to do this in a best practice way. Another sort of criteria is to drive to use products and services that are actually indigenous to the country of the certification. So 56% of the products and the labor and the services were all procured in Qatar. Qatari registered companies. In terms of, you know, this doesn't just mean the actual material products that make up the stadium. This is everything. So this is all the security, this is the labor force, all these kind of things. They're all done by Qatari registered companies. So it's a way of ensuring that you know, there's an economic benefit to building and seeing what that level is. I've got one more slide.
Yeah.
We're coming near the end now, but some more facts. The actual site where the stadium was sitting was a former Qatar Petroleum refinery site. So there was a lot of mitigation and cleaning up of the actual site that occurred. And this also meant that there were many trees. There were quite a lot of trees taken from the site and stored in a tree nursery from the client, the Supreme Committee. So they actually stored the trees and they've reintroduced them onto the site and onto other stadium sites. It's basically a feature that it's been. There were some very mature trees, some of them 25, 30 years old, that were that were uprooted, stored in a nursery, and then relocated for the final for some of the stadiums. And in terms of heritage features, the site had lots of tanks and or pump features and stuff coming out the ground, and many of these were retained to be used as to denote the legacy of the actual site in terms of its former refinery usage. So that was another way of earning recognition from the certification authority. I think the last slide is the last slide. And the next slide. So yeah, any questions? Anything that this has thrown up in terms of queries from the audience? I'll be happy to answer.
Yes, sir. So any questions? Anyone?
Oh, hi.
So,
Thank you very much, Mr. Shashi Narayan. I had a couple of, I'm just curious about certain things. How this decision of using this containers and then, you're planning to make a stadium, and that now in that process, you're trying to uproot the trees, and then what will happen when you just demounting the whole stadium? And again, I mean, how about the plantation? So two things.
So-
And how did somebody, so what was the evaluation done in terms of energy, in terms of reusing the things, in terms of the construction, in terms of time? What was the main aspect behind going with this kind of construction technique? Was it an innovation, or was it just talking only about sustainability? I mean, what's that?
So one of the main issues of tournament facilities for any major tournament, whether it's the Olympics, whether it's the World Cup, is what to actually do with the facility after the tournament has finished. So it's a 1 month long tournament, so all the facilities will be used pretty much 100% during that time, but what to do with them afterwards. So the whole aspect of what to do with it, they call it the legacy use, with this stadium was addressed by the fact that the stadium won't be there anymore afterwards, and the whole aspect of keeping it in use in different locations which need this type of facility. So it just, in terms of its actual practicality, the fact that it can be continuously reassembled and reused in different locations is one of the primary sustainability motivators. In terms of energy, they had a very specific criteria for energy usage in the facility, and this was measured by a very detailed set of spreadsheets and calculators, which were all interrelated. So everything to do with the actual lighting, the ventilation systems for the enclosed spaces, the pump energy, everything was put into this calculator to actually ensure that it was in the right range to be considered energy efficient in use. And this is the same with the water usage as well. So all of the water fittings and fixtures are they're low flow, and is, you know, they're optimized in the best way possible. Overall, in terms of the actual, you know, carbon intensity aspect, we're looking at, yes, steel is a high carbon emitter in production, but the whole fact that this was going to be repurposed and reused and not demolished afterwards was one of the main plus points we had in terms of using the system. Technology-wise, innovation-wise, I think this is all to do with the actual fact that everything has been considered in a demountable way. That's been kind of at the high priority in terms of the design stage. There was no, you know, that had to be kind of incorporated into the DNA of the design. How is it going to be, not just how it's going to be constructed, but how is it going to be deconstructed? And this actually drove the thought process with the engineers and the structural teams from an early stage. Does that respond to your questions?
So we have one more question from Mr. Arvindar. He says, regarding the life cycle assessment of materials used, do you start with deciding how long the building is going to be used?
So in terms of the life cycle assessment, is to do with the individual products and materials. So it's to do with the actual components, and life cycle assessment is looking at what has been the impact of producing that material. The actual lifetime of the building is obviously important as well, but it's got to do with you know, understanding what's making up the ingredients that bake that cake, and obviously, you know, how long that lasts is important as well. But this is the whole point of the looking at the LCA and the environmental product declarations, is to understand, you know, what is it made of, and how have they made these materials, and what impact has that had on the environment, you know, in terms of emissions to the air, to water, in terms of the energy that it's taken to produce the material. These are all considerations, and you know, if you're looking at highly performing materials that have very good EPDs, then you're going to be, if you're incorporating that into the end-to-end building, you're going to have an overall building that's very, very proficient and efficient, and you can actually show that it has had a lesser effect on the environment. And the fact that it can be repurposed and reused, it just goes to show that you're not creating any more landfill waste. You are actually keeping this in use as long as you can.
I hope, Mr. Arvind, you got the answer from the speaker. Yeah, he says thank you for your reply. Sir, would you like to share any anecdote regarding the construction, while the construction was going on?
There's lots of anecdotes. I mean, the client is very, very happy with the whole concept. It was a very hard sell from the design team, but you know, through actual, you know, lots of persuasion, they did manage to keep the concept pretty much intact. And the client is so excited about the demountability aspect. They actually want to take the building down before the games have actually finished to show that it is actually demountable. So it's literally going to be the whole performance aspect of it being deconstructed is hopefully going to be evident before the actual end of the World Cup. So that's something that we've sort of talked about. And obviously also the name of the stadium. Why is it called Stadium 974? Well, 974 is the dialing code for Qatar, the telephone dialing code, but it's also the number of actual individual shipping containers in the entire structure as well. So something memorable in terms of its actual name and where it started from. So yeah.
Okay, and as you said, no, there is total natural ventilation. So can you just throw light on this natural ventilation, because you are just using the natural, energy, wind as well as light. And,
that's right.
Yeah.
So because of the time of the year that these games are happening, they're happening in November, December, and the normal temperature at this time is in Qatar is entirely acceptable. You've got a range between sort of 16 or 17 degrees to 25, 30 degrees. So it's not hot. It's not anything like the temperatures you're getting in the summer. And so in terms of the actual seated areas where the spectators will be, the modeling that was done ensured that there was adequate cross ventilation. There's openings at a high level. There's the actual stadium is obstruction free at the higher levels of the facade to actually allow air to permeate through. So and it's obviously located next to the water side, which is a bit more cooler as well in terms of the actual breezes that come off the Doha Bay as well. So on that level, it's all been modeled in terms of the actual different temperature profiles, and there's nothing that's come to pass. In some of the other stadiums, we do have air conditioning that's delivered at seating level, but even in those stadiums, none of the air conditioning will be used during the time of the tournament. The comfort levels and the profile is completely fine. And in terms of the AC within the internal spaces of the stadium, that's been assessed and optimized to be the most energy efficient in terms of air delivery and ventilation that's possible. So that was the only way that was actually going to get through the actual GSAS process, which incidentally, if you fail energy, if you don't get the minimum requirement for energy and the minimum requirement for water, you don't actually get certified. It's basically mandatory requirements. So there's a constant focus from the technical teams on this issue and whether or not it's going to actually be acceptable to the GSAS authorities. So it's always in the front of their mind to make sure that it's actually working, because in the same way that the client asked for a roof to be constructed, the client also asked for a GSAS certification, at a minimum level. And so this is something the contractor could never ignore, that it was a contractual requirement to provide this level of performance. And that's what's been achieved, thankfully.
Okay, and so would you like to throw some light regarding the reduction of water consumption in the entire process?
Yeah, sure. We've got, so basically on the market available, we've got very, very efficient systems. So they're cutting water on average throughout the stadium by 60 to 70% in terms, if you compare it to normal flow rates. So in terms of so the taps, the faucets, they're all low flow. All of the WCs, the showering facilities, everything that uses water has to be within a very specific range in terms of liters of water used. per flush, or you know, there's dishwashers in the catering facilities, stuff like that. They all have to be compliant. So I think on average the figure has been about 60 to 70% reduction across the entire facility.
Okay, sir. Sir, there is one more question
Yeah.
from Anubhav. He says, are all these 8 venues for the FIFA constructed using the same method, I mean demountable container, or this is the only stadium?
This is the only stadium using this concept. So if you go to the Supreme Committee's website, it's a very easy website to remember. This is sc.qa. It'll show you all the 8 different stadiums. They're all of varying sizes. This one is the Stadium 974 is a 40,000 facility. There's a stadium with 65,000 seats, which is modeled on a traditional tent structure that you find in Qatar. Then the main stadium, one of the other stadiums I was working on, 𝗀𝗲𝗇𝗧 Stadium, that is 85,000 seats, and it's based on one of these welcoming bowls that are used to serve dates, sort of structure and look and feel of one of those bowls. So there's lots of different varieties. One of the stadiums was actually an existing stadium that was extended. It was previously the national stadium used for the Asian Games in 2005, and that got extended and made compliant. So yeah, there's a variety, whole variety. 8 stadiums. This is the smallest area that the FIFA tournament has ever been held in, and it will mean that people can that are attending the tournament, the games, spectators can actually go to more than one stadium in one day to watch more than one match, which hasn't been possible before. So that has its own environmental benefits in terms of reducing traveling times and you know, the impact in terms of pollution and stuff. But yeah, they're all very individual stadiums. All they have their own character. All of them had to be GSAS certified. And the one I've just shown you is just one of the examples that we were involved in.
Okay. There's one more question from Mr. Arvind. He says, what was the rationale behind going for shipping containers versus maybe CLT panels for the walls, for the structure underneath the seating? And is it because there was easier access to shipping containers, since Qatar is one on the main route of the shipping trading, or any other reasons?
So in essence, the reason for shipping containers, the original designer is a Spanish firm called 𝗀𝗵𝗃. So the idea behind containers was they would actually be reused as containers, and because obviously the shipping container is a robust element, it can last a very long time. That's what the decision was made, to have the actual individual units. So if you use something like CLT, timber-based products, whilst you can take them apart, when you take them apart, they get damaged, and then when you put them back together again, you know, that damage is still evident. So the whole aspect of using an element that can be robust enough, be strong enough to be reused, and also to protect whatever's inside. So many of the shipping containers are fitted out inside with different kind of finishes. You know, some of them are offices, some of them are cleaning WC facilities, stuff like that, and they've all been considered with finishes that are robust enough to last. But the interiors can be changed in the future if the new owners want to do that. But on the outside, you know, having a robust shipping container sort of product or model was something to ensure that it did get reused and repurposed as often as possible.
So I have
and first and foremost, they are certified as shipping containers. They're not just pretend. They can be put on a boat and taken anywhere in the world, and they've got the certifications to prove that they are, you know, bona fide shipping containers.
Another question from Mr. Arvind.
Yeah.
Whether, just a minute, sir, I just lost hold of the message. Mr. Arvind, can you just share your question? It was regarding whether, the containers are virgin or they were already, in use.
So they were actually produced for the project by one of the world's largest producers of shipping containers, a Chinese company called CIMC. So they were, and their day job is making shipping containers every day. They are one of, I don't know, maybe a handful of companies that do this on a large scale. And yes, so they were made specifically for the project, but with the whole idea that they could continue their life as shipping containers even after the usage in this stadium.
That's very great. Sir, I have a question regarding the foundation. You said, they can be just taken up and be shifted. So if you have the same capacity and the same typology of the structure, then and then only those, type of footings can be used.
Yeah.
So that means this demountability or deconstructionability is limited to stadium structures only. And with
so the maximum size of structure is limited to all the elements that are in this stadium. You can do smaller configurations. You can do, the different options that the designers show, that you can have a circular configuration. It could maybe be turned into a tennis court, but it can't be turned into anything larger than what we're seeing now. This is the largest configuration in terms of that number of stories, the stackability. But yeah, everything below that in terms of configuration, it can be done. Yeah.
Okay, thank you very much. Any more questions from anyone? Thank you very much, sir. I think with this, we end up the session here. Thank you very much to be on the board and deliver such an insightful session. And
yeah, apologies for the technical issues earlier on.
No mind, sir. We always come across such kind of technical glitches, so not an issue. Yeah. So that is why I asked you in advance for the presentation, that if any setback is there prevailing from your side, I can able to at least share the screen. So I thank everyone and to be on this session. And so we are very much thankful to you for your knowledge sharing regarding this construction and design aspects. And we look forward for many more cooperation with 𝗀𝗃𝗃 University, your association as well in the future. Thank you very much, sir.
Thank you for the invite. Thank you very much.
Thank you very much, sir. So with this, we end up the session. And before I think everyone leaves, I would like to remind you for the next upcoming session. It is being, being delivered by very known LinkedIn person, Mr. Mehtash Soltani. He will be delivering the session on this road barrier systems, evaluation and design. So please be connected with this FT lecture series and join us for that on 11th March. Sir, even if you are, able to connect with us on that particular day, we would be obliged for the same. Thank you. Thank you very much, everyone.
Thank you.
Thank you, sir.